Assalamualaikum friends, my name is Abdul Rahman. Today I tell you the answers of 20 questions of transformer. Question number 1. Is the turn ratio of a transformer the same as the ratio of voltage across the transformer? Why or why not? It is observed that ratio of voltages of transformer are same as ratio of their turns because flux linkage both the coils is same, so voltage will be directly proportional to number of turns. Mathematically, Vp upon Vs is equal to A is a turn ratio, A is equal to Np upon Ns. Number 2. Why does magnetization current impose an upper limit on the voltage applied to a transformer core? The core maximum MMF defines both the maximum voltages frequency and coil turns, and the linearity of the magnetization current. When higher voltages are applied, the core saturates and the magnetization current rises to produce an ohmic voltage drop in a wiring, which will eventually burn out. Question number 3. What components compose the excitation current of a transformer? How are they modeled in the transformer equivalent circuit? It consists of two components: the magnetization current, which is the current required to produce the flux in the transformer core, the core loss currents, which is the current required to make up for hysteresis and eddy current losses. Question number 4. What is leakage flux in the transformer? What is it modeled in a transformer equivalent circuit and an inductor? Flux extends from the pole sides. This flux is not doing anything other than wasting energy. Therefore, leakage flux is modeled as an inductor because it is inductance. Question number 5. List and describe the types of losses that occur in a transformer. Hysteresis losses. The reason is the reversal of magnetization in the transformer core. This loss depends on the volume and grade of the iron, frequency of magnetic reversal, and value of flux density. Core losses. Eddy current losses and hysteresis losses depends on the magnetic properties of the material used for the construction of the core, so these losses are also known as core losses or iron losses, copper losses. These losses are accounted for by the series resistance in a equivalent circuit. Question number 6. Why does the power factor of a load affect the voltage regulation of a transformer? The lagging power factor demands more current and it causes more voltage drop in a transformer windings. As a result, the voltage regulation of the transformer deterioration. Question number 7. Why does the short circuit test essentially show only copper losses and not excitation losses in a transformer? It is essentially because secondary side of a transformer is open circuit. There is no output power, hence this power only consists of core losses and copper losses. Question number 8. Why does the open circuit test show only excitation losses and not copper losses? In the open circuit test, a transformer secondary winding is open circuit and its primary winding is connected to full line voltage. To calculate the value Rc and Xm is 100, look first admittance of the excitation branch. Gc is equal to 1 upon Rc and the magnetization is given by Bm is equal to 1 upon Xm. Question number 9. How does the per unit system of measurement eliminate the problem of different voltages levels in a power system? In the per unit system, the current, powers, impedance, and other electrical quantity are not memorized in the usual SI units volts, amperes, watts, ohms, etc. Instead, such electrical quantity is measured as a decimal function of some base level. Any quantities can be expressed on a per unit basis by the equation. Question number 10. Why can autotransformer handle more power than conventional transformers of the same size? It is interesting to note that not all the power traveling from the primary to the secondary in an autotransformer goes through the windings. As a result, if conventional transformer is reconnected as an autotransformer. Question number 11. What is transformer tapes? Why are they used? Tapes provide a means of maintain the appropriate magnetic flux levels in the transformer to provide the transformer's rated secondary output voltages. Tape are usually supplied on the primary or input side. This is useful to adjust the output voltages if the input voltages differs from the normal voltage. Question number 12. What are the problems associated with the YY three-phase transformer connections? A YY connected three-phase transformer can produce severe tank overheating that can quickly destroy the transformer. This usually occurs with an open phase on the primary circuit and load on the secondary. Question number 13. What is TCUL transformer? A TCUL transformer is a transformer with ability to change types which power is connected to its voltage regulator is the TCUL transformer with built-in voltage sensing circuitry that automatically change tapes to keep the system voltage consistent. Such special transformers are very common in modern power systems. Question number 14. How can three-phase transformer be accomplished using only two transformers? What types of connection can be used? What are their advantages and disadvantages? Three-phase transformers consist of the transformer either separate or combined on one core. The primary and secondary of any three-phase transformer can be independently connected in either a Y or a delta. This gives a total of four possible connections for a three-phase transformer bank. First one is YY, second one is Y delta, third one is delta Y, fourth is delta delta. Advantages: it cannot handle the overload as such. It might damage the equipment and the chances of costly repairs are higher. Because the unit voltage is very high, a three-phase power connection requires high insulation costs. Disadvantages: if load in the transformer circuit are unbalanced, then the voltage on the phase of the transformer can become severely unbalanced. Third, harmonic voltage can be large if three-phase set of voltages is applied in YY transformer. The voltage in any other phase, however, the third harmonic components of each of the three phases will be in phase with each other. Since there are three cycles in third harmonic for each cycle of the fundamental frequency. Question number 15. Explain why open delta transformer is connection is simultaneously supply 57.7% of a normal delta transformer bank's load. The rated current is the same in each transformer, whether there are two or three of them, and the voltage is the same on each transformer, so the ratio of the output power available from the open delta bank to the output power available from the normal three-phase bank is the original power output out of the open delta bank is only 57.7% of the original bank's rating. Question number 16. Can a 60 Hz transformer be operate, operated on a 50 Hz system? What actions are necessary to enable this operation? Thus, if a 60 Hz transformer is to be operated on 50 Hz, its applied voltage must also be reduced by one-sixth of the peak. Flux in the core will be too high. This reduction in applied voltage with frequency is called derating. Similarly, a 50 Hz transformer may be operated at a 20% higher voltage on 60 Hz if this action does not cause insulation problems. Question number 17. What happens to a transformer when it is first connected to a power line? Can anything be done to mitigate this problem? If rating is correct, terminals connections are correct, if safety devices are in place, if a device is a standard with necessary requirement, it should not be problem to connect a transformer first time. Question number 18. What is potential transformer? How is it used? The potential transformer designed to handle only a very small current. The second type of special transformer is designed to provide a secondary current much smaller than but directly proportional to primary current. A potential transformer is a specially wound transformer with a high voltage primary and low voltage secondary. Question number 19. What is current transformer? How it used? Current transformer simple current in line and reduce it to a safe and measurable level. A current transformer described in this chapter is that its windings are closely coupled Unlike all the others, the transformer, the mutual flux in the current transformer smaller than the leakage flux. Question number 20. Why does one hear a hum when standing near a large power transformer? This is when the current is flow through the transformer coils, creates a magnetic field, then changes the dimensions of the transformer iron core. The core expands and con- constrict with the alternating current, which cause a humming sound. Thank you.